Hello, everyone, and welcome back to the cardiovascular diseases section. From the second part of the course, we're looking at engineering the cardiovascular system, and I'm going to give you a quick summary of what we've looked at so far in terms of cardiovascular disease. We've looked at vascular disease. Let me just quickly go back and look at those slides. So we've looked at vascular disease, which the main ones that we've covered are arteriosclerosis, pertains to any artery, and it can include atherosclerosis and arteriolosclerosis, which include the arterioles. And the second one we had was aneurysms. So aneurysms was also enlargement of blood vessels rather than the thickening of the wall, which was the case in arteriosclerosis. And this we saw that could happen both in the brain and also the aorta. And then we looked at the heart diseases rather than vascular disease. Here we're looking at the heart diseases, so the ones that immediately and directly influence the heart itself. And we had a congenital heart failure, which happens from birth, versus congestive heart failure, which we saw that as a lack of function, lack of performance of the heart, that gets worse and worse as you move forward. And that's why in the elderly, this actually causes and leads to hospitalization, because they can no longer keep that going. The heart performance just gradually reduces more and more. And then we looked at congestive heart failure. We noticed that similar to vascular diseases, where we have flow rate in the blood vessels influencing the permeability and integrity of the endothelial cells, it is the vorticity and the vortex nature of the entrance of flow from the atrium to the ventricle in the left-hand side that has a key major role in the circulation of the blood and the pumping performance of the heart, because this vortex then aids and optimizes the pumping through the aorta from the left ventricle. If it doesn't exist, if it is for any reason facing some issues in terms of its progression through the ventricle, if it's affected by any of those fluidic features of the left ventricle, it can actually cause a significant reduction in the performance of the left ventricle and the heart in general. And we also talked about congenital heart disease, another subcategory of heart disease. And now we're looking at other cardiovascular diseases, specifically focusing on valvular diseases, the diseases that attack or target your valves rather than well, it's still part of your heart, but rather than that being your ventricles, it's actually these gating sections, the valves that allow the flow in and make sure that the flow doesn't go in the direction that's not intended. So valvular disease is the main section we're going to focus on right now, but you'll see that tissue necrosis and ventricular fibrillation are another sort of thickening and formation of extra material inside the ventricles that do not belong there, and can then disturb the natural flow of blood through the heart ventricle. And so we're going to focus on valvular disease. And to start, I'm going to just give you a quick recap of what we covered in terms of the heart valves. So we've got 4 heart valves. Remember that still. We've got the valves that bring blood from the heart to the entire circulation and back from the entire circulation to the heart, which are these 2 large valves in the extremes here. One is the tricuspid valve that connects the right atrium to the right ventricle, bringing blood from the circulation into the right ventricle. And one is the mitral valve, which connects the left ventricle to the circulation through the aorta. And what happens in this case is it's bicuspid valve. In other words, it has only 2 leaflets rather than 3. And then we've got the other 2, which are, we call them semi-lunar valves. One that goes through, as you can see here, through to the aorta, and the other one that actually goes to the pulmonary circulation. And sorry, I just misdescribed this one. The mitral valve is what connects the atrium to the ventricle on the left hand side. And so basically these 2 have a design that's also similar to the tricuspid. It's a 3-section semi-lunar valve. In other words, what it means is that it's got 3 cups here, and the geometry is very much like what you see here. These cups fill in this direction, therefore block the flow. In that direction, they can easily collapse. It's a beautiful feature here, as you can see, of the heart. And so these 2 that carry the main flow basically from atrium to the ventricle, bit larger than the other 2 here that carry flow again to the pulmonary or to the entire circulation. These 2 have a one-way function, the other 2 also, but they're a little bit less rigorous on that. Because of this structure, this has a much better efficiency in doing that. So these are our 4 heart valves, and now we're going to look at the different ways in which they can become unhealthy. So when we're talking about unhealthy conditions of the heart valves, we're talking about 2 extremes. One is calcification, where they become very stiff, become really rigid, and it also influences the leakiness. And one is just, accumulation of fatty acids and becoming more and more bulkier. So now there are 2 classes. So the first one is regurgitation, and it's good to know that, basically when we're talking about heart failure, we're talking about the loss of efficiency or performance of the heart. When we're talking about valve failure or valve disease, we're talking about the valves also losing their performance, and their performance is to be very tightly regulating the blood flow. So if they become leaky, that's when they're actually going to be diseased. So in the case when they don't completely close, we call it regurgitation. They become leaky, and that's similar to here. You have calcification. It's become stiffened. The flexibility and the compliance isn't there, so they cannot fully close. Similarly, you can have it here where you have a prolapse here in the mitral valve. This example is the tricuspid. This is the mitral valve connecting the left atrium to the left ventricle. And in this case, again, the prolapse is causing it to not be able to fully close in the cycle. And so that means you're going to have some leakage, which this leakage isn't going to get better through time. It's just going to get worse, as you can see. It's going to put the heart under more and more performance requirements. Basically, whenever you have a lack of performance, it's going to overload the heart and make it have to do more, and that will change the tissue remodeling involved in the composition of the walls of the heart, because it has to perform differently. Now, this tissue composition can change as you're young, but as you become older, it's going to be more and more challenging. That's why we have hospitalization. When you're young, if you increase your activity rates, etc., you can force the remodeling of your heart into a more, into stronger, more robust pump. Although you're also changing the mechanical properties, so it can be good or bad. It's mostly good when it comes to younger ages. When it comes to the elderly, and the heart has to adjust to the change of performance caused because of, let's say, a valve leakage, this change of mechanical properties can then cause arrhythmia and, you know, many other cascades that can happen. So anyway, back to what we were saying, whenever they become leaky because of not being able to completely close, we call it regurgitation. And then when the opening is narrowed and stiff, and the valve isn't able to fully open, right, you see here in the image, it's called stenosis. So it's, you know, the opposite side of this is, so, you know, there's accumulation of material in the surrounding, and the valve just cannot manage to fully open, right? And allow blood to pass through with the same flux as it was before. Okay, and usually these again happen because of either the stiffening, calcification, or stenosis. See here, you've got a severe case of buildup, and it can also happen because of prolapse here and deformation in the geometry of the mitral valve. So again, these are the two cases where you have a specific, very well-defined change in the functionality. Either it is allowing blood to flow where it shouldn't and it's become leaky, or it's actually unable to allow blood to flow with the same flux rate, and therefore it's stenosis. And again, these two happen because of these three material causes, reasons. So looking at heart valve problems in a little bit more detail again, here you see stenosis, as I mentioned a minute ago, and these build-ups are not allowing the heart valve to properly open and close. The stiffening of the calcification is the same story. That also is going to make it harder for the heart valve to open and close. So in terms of diseases, again, we have three distinct categories. Rheumatic diseases come from an infection, and in a lot of the countries, antibiotics are not used for you know, certain types of infection. So if it actually continues on, it can cause a damage and tissue scar in those regions because of the bacterial lump. Whenever it detaches, it can actually leave behind a scar. This is actually, interestingly, the most common cause of valve disease. And then you've got endocarditis, and this is the case where the infection in the blood, it happens in the blood, that's where it happens, and then the infection in the blood actually moves on, and then as it flows through, it settles on the heart valves, and it grows on the heart valves, and it just continues on from there. You can have scars on the heart valves, but also they can just damage the native tissue when it becomes a prolonged infection there. And then you have congenital heart valve disease, which is something that again starts from birth. Nothing you can do to avoid that, but you just have to then have a replacement or something. And in some cases, it's something you can live with, but it's very, you know, rare. So for instance, you can see two leaflets in the aortic bicuspid valves. You can actually you can see a different type. So you can see, rather than having two leaflets, you can have three leaflets, or rather than having three leaflets, you can have two leaflets, which is quite bizarre. But this can cause, this may be livable, maybe absolutely fine, but it can cause such significant changes in the performance of the heart circulation that it actually has to be replaced for it not to cause downstream events that are even worse. So this is the last section that I wanted to cover in terms of the cardiovascular diseases. Just to summarize, we've looked at diseases that involve the circulatory network going from the heart to the other organs. And this can happen either in the main branches, the aorta and the arteries, or it can happen downstream, even in the capillary levels, which we haven't really talked and discussed anything about the capillary diseases, but in those sites, it's usually the lack of integrity, the leakage of capillaries, the rupture that can happen because of high pressures. We're not covering that, but the main ones that happen are the artery and aortic levels. Then we talked about heart disease, which is the loss of function of the heart, and finally the valvular diseases, again part of heart disease, but more understandable from a mechanical perspective. As we will look at heart valve replacements, we'll see how the function matters quite a lot. So I'm going to conclude here with the disease section, and moving on to the next lecture, we will talk about devices, biomedical devices used to tackle some of these heart disease and what the strategies are. It's going to be a lot more exciting looking at the engineering solutions that we found to tackle these diseases. So please stay tuned and watch the next lecture very carefully. Thank you very much.